Alright, so we're quickly just going to go over mesh setup. Now you can do this with your imported mesh, but I'll just create a cylinder with some issues to show what you might need to adjust. So first, we make sure the mesh is scaled properly and facing forward on the global axis. You can make adjustments to your mesh and then go into the modeling mode and bake the transform. And then next, you need to edit the pivot or the origin, whatever, to be in front and at the bottom of the flashlight, so that if you drop the flashlight on the ground, it wouldn't clip into the floor. And with that, your mesh is set up. Let's move on to the next step. Now it's time to create the flashlight prefab. Right-clicking in the content browser, we can go ahead and create an entity prefab definition. Name it whatever you like, then save all and build verse code so that the mesh components for our static meshes are generated. Anytime you create a static mesh or import one, you must build verse code or you won't be able to see or use them in the entities. Now in the prefab editor, start by making a child entity that will hold the mesh and light components. We are doing this instead of placing the components directly at the root because it makes it easier to position the flash wherever you want, as well as make the math easier as well. Next, we can drag the mesh directly into the details page, just like so, and it'll automatically add it and as a mesh component and also create a transform component. Then add in a transform component to the root entity as well. And now we have the child, which we can position anywhere in this space, while the root gets attached to the player's pelvis later. I want to set the position of the flashlight relative to the player. Personally, I want it floating in front and to the right of the player. So first, I'll just set up my reference by dragging the prefab we just created into the scene and placing its root somewhere along the center of the player model here. Once again, when you set the player entity as the origin of your custom entities, the origin is at the pelvis of the fourth character. Now you can fiddle around in here and try to adjust the position while going back and forth and checking, but there's an easier method. See, by right-clicking on the prefab in the outliner and selecting Edit Prefab in Place, here it's telling us it will close the other editor windows for this prefab that are open. That's fine. Now, we can edit this prefab, but in the viewport. So, select the child, pose it wherever you want relative to the player, then hit save, and boom, you're done. Now we can go back into the prefab editor and add the rest of the components for our flashlight system, starting with the spotlight component, which will be added to the child entity. Here, I'm just setting a few default values for the light. Next, I'll add a keyframed movement component to the root because we will be creating a pickup animation later on. And now, to add the rest of the custom components we will be using, normally you would just click add, then create new verse component, but I've already created them, so I'll just go ahead and add them here to the child entity, not the root, the child entity. First, the main flashlight component, then a custom interaction component, and the reason for making the custom one instead of just using the default is just so we can change the interaction text for pickup. And that's it. Finally, we can move on to the component definitions in verse. First of all, tags for your input devices. Because you're going to be able to spawn this at runtime, we can't do editables because. So what we're going to do is we're going to tag our input devices, and anytime a flashlight is spawned, it will reference those input devices. Here we have a toggle state tag. This toggle state also will be used for dropping the flashlight. And then we have brightness increase and brightness decrease tags, which you will add into your input devices. And these input devices have the tags for each. And most importantly is for all of them to require registered, so that you can have these input devices and you could have other input devices reading the same input, but it won't necessarily affect those or affect this. And here I just have a component helper. I'm going to move this to my helpers function. Okay, thank you, Buke. Okay, so here we're going to go first over the flashlight interaction component, which just inherits from the interactable component and lets you set the text. And then interaction duration, just ignore this. What is important is that you inherit from this and you override this message. This is how you set the text that will show up in game. You override this, which is a function in the actual interactable component. So you override the function and then you can set the text to be whatever you have up here. So that's all it is. This is the only way you can set the text, by creating, one of these guys. And now we'll go to the flashlight component. So here I have a bunch of variables that are editable. This is just for customization since I'm going to be putting this on the Patreon. But we have hold duration to drop. What this does is how long you have to hold the button that toggles the flashlight so that it drops instead of toggling the flashlight. And then max brightness, how bright the flashlight can get in game. And then we have brightness adjustment step size. This is the incremental value, like how much it increments by or decrements by. So for example, by combining these two, you could do stuff like set flashlight stages. So let's say, for example, you want a flashlight that is 3-step. So like dim, normal, and then bright. What you could do is just set this to be something like, 0.9 or 90, something divided by 3. And then set this to be 30. If this is 0.9, this would be 0.3. And then your flashlight will go in 3 stages, up and down. And then use animated pickup. What this is for is if this is set to true, you will, when you pick up the flashlight, it'll animate from wherever it is to your, to the position where it's attached to the player. If it's not, once you pick it up, it just automatically just snaps. Pickup animation speed is how fast it does the animation. Allow item drop. If this is set to true, you will be able to drop the flashlight. If this is set to false, you won't be able to drop the flashlight. You won't be able to drop the flashlight. Now, because toggle state and hold and dropping are like based on the same input trigger, if you turn this to false, you will also need to make sure that you go to your toggle state and you do not like add this text here just because. Okay, so allow manual state toggle, set this to false, and they won't be able to turn the flashlight on or off. Turn off when dropped, pretty self-explanatory. If it's on, when you drop it, it will always turn it off. Allow manual intensity adjustment. This just controls if they can, set the brightness up or down. And then use pitch correction. The way attaching stuff works in scene to setting the origin, it doesn't set it to your camera. So if you look up and down, normally it wouldn't affect the pitch of the flashlight. The flashlight wouldn't look up and down, wouldn't go up and down. So if you want that behavior where the flashlight is always level, set this to false if you want the flashlight to always be level. Set it to true if you want the flashlight to not be level. And then drop at feet. If this is set to true, the flashlight will always drop at the player's feet. It will drop at the player's feet right here. If it's set to false, it will always drop straight down. So that is what drop at feet does. And then we have some variables for the input triggers. We have a variable for someone who may be who owns the flashlight. It's an optional. And then we have, if the light is, we have a variable for the light state, if it's on or if it's off. Now, and then we have also cancellables, a cancelable array. We have this for 2 reasons. First is so that we can store our subscription. We can reference our subscription in this variable. What this does is it makes it so the garbage collector won't eat up the subscriptions and effectively stop them from working. And also, it also lets us, when like the flashlight is being removed from the scene, we can cancel the subscriptions. When the simulation starts, it will get the light components, which has to be on the actual flashlight itself, not the root. Again, just reiterating. and then it will check its state and it'll initialize this value pretty much. So this way you can either have this start out off or on, and you know, it just works. And then after that, we get the interaction components, and then we subscribe to this function, which is pickup flashlight, which is for the interaction component. We subscribe to it. This is a custom wrapper, which you can use to subscribe to functions with the suspend effect. It's in here. I'm not going to go for it either, but you subscribe to this pickup flashlight. And the reason why I'm actually subscribing to a suspend function, because the only thing that is suspending about this is the fact that in the animation, this is like a quirk of SceneGraph, but when you set keyframes and you play right after, there's a chance that it just glitches. It hitches, not glitches. It hitches a little. So if you sleep to the next tick before you play, it's smooth. So this is the only reason why this is here. So you can get rid of this and get rid of that, and then just do a regular subscribe without the suspense. So yeah, on interaction, we get the interaction component, and then we set our cancellables array. We set our cancellables to an array, because it takes an array of option, because it is optional, to the interaction dot succeeded event. This is in the interaction component, succeeded event, and we subscribe to the pickup flashlight. And then after that, we set our cancellables to on fort round start array. What this is, it's a custom helper function that simply lets you, everything you pass to this in the array will only run when the Fortnite round starts. And we're doing this because we're adding the input triggers. And the input triggers, we need to get the creative object with tag. So we tagged the input triggers in our level. We need to get the tagged object, and this only runs when the game has actually started. So if you try to run this when the game hasn't started, it wouldn't find the tagged objects. So that's why we are subscribing to this function only when the round starts. Okay, you can also use this for any other thing you like. If you want to have a bunch of stuff, just put them in an array here, as I'm doing. So we're going to go, actually let's do this one first. So when on end simulation, what this is when the flashlight is being removed, it will unregister the input triggers from the player, and then it will cancel all of the subscriptions. So that's what this is. So let's just go to the add input triggers. So first things first, it will get and set all 3 devices. That's what this is. And then it will also subscribe to the functions that those devices do. So the first device, which is the toggle light, it should be toggle light and drop, but anyway, the first, actually, let's just rename that real quickly. Toggle light underscore drop. Okay. So the first device, which toggles light / drops it, it'll subscribe to the handle toggle button release. And then the second, it'll subscribe to increase flashlight brightness and decrease flashlight brightness. We're going to get to these 3 in a bit, but let's go over to register input trigger. Basically, it gets the agents, and then it will check if they are allowed to toggle the state. If they're allowed to toggle the state, it will register this. If they're not allowed to toggle the state, it will not register this. Then it'll also check if they're allowed to adjust the brightness, and it will register the input triggers for those actions. And then unregister just unregisters everything from the player. So that's what this is. That's what these 2 are. So then we're going to go to these 3. Handle toggle button release. We're subscribing to the released event of the input trigger, and that's so that we can get the duration that it was held for. Okay, so here we store the result in a release result, and then we check if the person who released it is not the owner of this flashlight, because you can have multiple people and it will fire. If the person who released it is not the owner, just return. Just don't do anything else. But if the person who released the button is the owner, then we will check if we're allowed to drop the item. If we're allowed to drop the item and the duration which they held it for, which is this, is greater than or equals to the hold duration, which is this, then we will drop the flashlight. But if it's not, then we will just turn it on or turn it off. Okay. That's what this does. And then we then go to the pickup and the drop functions. Oof, okay. So the pickup function, what it does is if the player is already holding a flashlight, which is a function that's described down all the way down here, we'll get to it in a bit. If the player is already holding a flashlight, don't pick up the flashlight. So this just lets you not have two players stack two flashlights. And then otherwise we get the interaction and then we disable the interaction. You can delete this line. I don't know, actually don't delete this line. But what this line does is it makes it so the interaction, when it's picked up, it's, it disables that. And then we set this value, maybe owning agent, to the agent who picked up the flashlight just now. So we set that here. And then we register the input triggers for which it'll just handle it because it already is listening for that. So after that, we will then do a bunch of stuff. So we will get the player entity, which is the agent who picked it up. We get the for character, and in the for character, we have the get entity function. In the for character, it's new. So, and then we will get the flashlight root, because remember, this flashlight component is on the object, not the actual root of the flashlight and prefab. So we will get the flashlight root by getting the parent of the entity. Now this entity is the entity that this code is on, which is the flashlight itself. So we will get the root, we'll get the animation component for the root, and then we will set, this is like the magic sauce right here. We will set the origin of the root. We will change the origin to be the player entity. So flashlight root dot set origin. This set origin takes in, it says origin here, but this is where you actually construct an entity underscore origin. And this entity underscore origin, you have to instantiate the entity that you're trying to get the origin of. So in this case, it's the player entity. So we get the player entity, get the origin of the player entity, and then we set that origin to be the flashlight root. Now the flashlight root will follow the player origin around. Now, one thing to note is that whenever you do this, it wouldn't snap. Oh my God, this is like scene graph extra, but it would keep the object where it is in local space and recalculate its local transform. So it'll stay where it is, and it will recalculate its local transform. What I mean by this is when you click on an entity in scene graph, what you have is a local transform, not the global by default. So like this, for example, this is the global transform. You can, okay, well, this is the local transform too, I guess. This is the global transform, this is the local transform. Okay, it's the same thing. But basically, now, let's say we duplicate this. This is like a little scene graph tutorial. And then we attach this cube to this cube. You see how it stays the same place, and now it recalculates its transform. If I were to detach this, you see that changed. So it actually does the same thing. Okay, my bad. Anyway, you set the origin, it will stay where it is. So when you pick it up, even though the origin has been changed, the flashlight will stay where it is in the world. If you move around, it'll move with you, obviously, but it will stay where it is. So now we then check if we're using animated pickup. And if we're using animated pickup, we already have the animation component, which is the keyframe movement component. We will set keyframes, And this is a function that builds pickup keyframes. Is right here. I'll get to it in a bit. So we'll build the keyframe, and then we will one-shot play, so it only plays once. This will get it from where it is to where it needs to be, which is, you know, hanging by your side. Basically, it'll get it from where it is to 0. That's all it does. So this takes, because when the flashlight is at 0, when the root is at 0, it's going to be right by your player. So that's all this is. It's going to get it from wherever it is currently to 0. And then we sleep because of the jitter hitching thing. And then we play the animation. But if we're not using the animated pickup, we just set the local transform to this. So 0 on the translation, 0 on the rotation, and then 1 all through on the scale. So we just do this and it'll instantly just snap into place. And then we check if we are using pitch correction, and then we will spawn this function, which is the function that will handle correcting the pitch based off of where you're looking. Okay, whew, that was a lot. Let's go into build. No, sorry. Let's do drop the flashlight. So when you drop the flashlight by holding to drop, it will unregister the input triggers. And then it will get the Ford character, the player entity, and the flashlight root. It will then reset the origin of the flashlight root. So it basically detaches it from your player. That's what this function does, reset origin. It will, you know, remove you from the variable, the maybe owning agent. It'll set it to false. It'll get your rotation, because now when you drop the flashlight, we need to make it point where you were looking at, pretty much. So it will get your player rotation. This is a helper function as well that just converts Unreal Engine rotation to the verse rotation. If I didn't have this helper function outside here, I would need to have the modules inside the actual flashlight. Let me just move these here. And if I did, then I would have to specify, I would have to do this thing right here where you copy this. I would have to put this in front of everything. So that's why it's out there. So yeah, we get the player rotation, we convert it to verse rotation. We get the view rotation. So we get the player rotation and then the view rotation. We're gonna use both of them. Are we? Actually, because no, we're not using both of them anymore, I guess. So we actually only need the view rotation. Whew. So we get the view rotation and then we get the yaw only rotation. So what this is the up. So let's see right here, boom. This is the yaw rotation. We want it to be, because when the flashlight drops, you kind of want it to drop on the floor and be level and not like looking up or down. So we need to take out every other rotation, but the up and down and like the roll around, and only keep the yaw, which is this. So that's what we're doing right here. So we're creating this using the function make rotation degrees. We specify the angle. The axis, and then the angle. We specify the axis, which is up. -1 is because the Fortnite character is actually like sort of like facing backwards. So you set it's -1 so it inverts. And then we, pass in the view rotation, which we got. And then we get the yaw pitch and roll degrees, which returns the yaw pitch and roll degrees, 1, 2, 3. And we need the yaw, which is the first element. So that's here. Oof, okay, so that's how we're calculating how it should be facing when you drop it. And then we also need the drop location. Holy coly. So the drop location I'm doing is based off of the player's position, knowing that the feet shouldn't be in anything. So if your feet is gonna drop at your feet level, that's what it's doing. So for the drop location, we get the player entity, we get the player's entity's global transform. We get the translation out of that. And then we subtract, which is how we move it down. We subtract an up value. Now this up value is going to be different. So if the player is crouching, we want to subtract 116. That will take it down to the feet. But if the player is not crouching and standing up, then we want to subtract 140. That will take it down to the feet. So that's how we get the drop location. And then we then check if drop at feet is enabled, because now we also need to do some offset to bring it from wherever it is, the actual flashlight itself, to the feet, not the root. Okay, so that offset, we get the entity, which is the flashlight itself, we get the local transform, we get the translation, and we multiply it by a vector of left and forward. Left and forward is just not including the height. It's not including the height. It's just this and this. So by multiplying it by that, we basically center it to the player. Because now you need to keep in mind we have the roots, which we're going to drop like this. And then to make this go to the feet, we need like these two components to be like here, essentially. So we just get the left and forward, and then again we do the same thing. We subtract this offset from the drop location, and then finally we set the flashlight root to be the drop location. So drop location will be this initially, and if this is enabled, it will change to, you know, to be that. And then we set the translation to be there, and then the rotation, we set it to be identity rotation, which is, it should have no rotation. And the reason we're doing this is because, which actually makes me think that we don't need this as well. I used to use this, but we don't need this either. I'll tell you why. Whew. So we set the base to be not have any rotation. It'll just be 0, 0, 0. That's what this is. How we actually calculate that yaw rotation to determine where it's facing is going to be later in here, pretty much. And then we enable the interaction again, so the player or anybody else can pick it up. And then we check if turn off when dropped is enabled and the light is on, we will toggle the flashlight, we will turn it off. Okay, toggle flashlight. It basically gets the light component. This is like extra, there's a sound component for the sound. Okay, so it gets a sound component. If you have sound on there, it will play, and then it will, if the light is on, it will disable it and set the light to be false. If it's off, it will enable the light and it will set it to be true. Enabling is how you turn on and turn off light components, by the way. It's not turn on or turn off, it's enable and disable. So, I guess I could, no. All right, so now moving on. Increase flashlight brightness. First of all, we don't want it to be able to increase when it's not on. So we check if the light is not on, or the person who's trying to increase is not the owner, then return. But if it is on and the person is the owner, then if light is not on, or so if it's on, but then this is not the owner, it will return. Okay, holy cow. Thank goodness I caught that. Okay, so that is how it is. If it's not on and the person is not the owner. So if you're the owner, it has to be on. If it is on, you also have to be the owner. And then, I feel like my brain is kind of going off here, but I hope this is right. And then if the light component, we get the light component, we get the current intensity of the light component, which is this in the spotlight component. And then we set the new intensity to be the minimum between the current intensity plus the brightness adjustment step size and the max brightness. So it doesn't go past this. That's what this is. I guess you could do like a clamp too, but this is easier for me. And then we set the light intensity to be the new intensity. We can also just do this directly, like this. But I'm just going to keep it. Actually, memory is precious. Okay. And then we have decrease flashlight brightness. And then build pickup keyframe. So what this is that it is getting the current translation. We're passing in the flashlight root not the flashlight itself. So it gets the current position, the local position, because now remember it's attached to the player. It's attached to the player when we call this. So we get the local position, we get the current rotation, local rotation as well, and then we build a keyframe which goes the inverse. So if you subtract this, it'll go from wherever it is to 0. And then if you invert this, it will also, because what this does, invert rotation, it makes a new rotation such that rotation plus the inversion is identity. And identity is just 0, 0, 0 all through. So that's what we do. And this will, it'll animate it from where it is to just be where it needs to be. And then you need to make the scale empty specifically, or it's going to be 1. This is additive, so it'll just scale a little bit. And then the duration is, I'm just doing like, you can set this to be a time value, but I'm just doing actual speed. So it maintains a constant speed across and doesn't like take a specific time. So this is just distance over time, or the speed. And then I scale it up a bit. And then the easen, I use easen out cubic as your easing function. So that's all this is. And then moving on to the pitch correction, which is a suspend function. It loops. So every tick, you want to get the player's view rotation. So you get the agent's for character, and you want to pass this agent. You don't want to do the maybe owning agent, because that will get removed, but this will always stay. So you want to pass the agent instead of doing like maybe owning agent. You don't want to do this because when you drop the flashlight, it will set this to be false, and you won't be able to get your rotation because it will be false, and this will fail. Okay, so you pass in the agent early on, and then you get the view rotation of the agent. It's a spatial math again, so we don't have to do the whole nonsense. And then we get the yaw only rotation, which is essentially what we did up there, but now we're doing it in here. So we're going to use this in a bit right here. So the first thing we do is we check if this is true. So if this is false, but then it's true because it's false, what we want to do, like if this is false, so we've removed the players drop the flashlight, we want to get the final rotation, which is just identity rotation. I didn't need to do this, but I was testing a bunch of stuff. And then if drop at feet is enabled, we want to set the final rotation to the yaw only rotation. Okay, yeah, I do need to do this, I remember. If drop at feet isn't enabled, it'll just drop straight down. It won't use the yaw, but if it is disabled, if it's enabled, then it will change the final rotation to be this yaw only rotation. And then it will set the local transform of the flashlight itself to be its position wherever it is, but then it will use this rotation. And this is how we keep the flashlight facing the same way when it's dropped. The reason why, by the way, just to mention, the reason why we are setting this rotation value on the flashlight itself and not, why we're setting it on the flashlight itself and not on the root is because remember the flashlight itself can drop to the feet, and if that happens, it's essentially going to look like this, right? So if we were rotating the root itself, then the flashlight would actually, wait, let's just, okay. Let's move this into position right around here. So let's say this is our flashlight and this is offset. This is bothering me a little bit. And this is offset like this. Okay. So when we drop at the feet, if we're rotating, when we drop this at the feet, which will look like this, if we are rotating the root, then the flashlight will essentially move away, which is why we need the root to be 0, 0, and then we need to rotate the actual flashlight itself. So that's why we're doing it on the flashlight and not on the root, if that makes sense. And then pitch only rotation. Oh, if we're not dropping, like this only runs when you drop it. So when you drop it, I don't have a variable for is dropped or whatever, but because when you drop it, it'll set this to false. So this branch would run and then break. So if we're not dropping it and it's just, regularly attached, then what we're going to do is just get the pitch only rotation, which is the up and down, right? Which is the same way, pretty much make rotation degrees, and then left -1 again, because Fortnite character inverted stuff. So if you look here like this, the red over here in this corner, that's the left. So this axis is the pitch only rotation. If you want it to be somehow, okay, I don't think you would ever want it to look up and the flashlight goes down. So -1, and then we get the view rotation, get your pitch roll degrees. So the pitch is the second element, which is 0, 1. That's what this is. And then we just set the local transform. Again, still keeping the translation, but now we're setting this. So every loop, if you're not dropping the flashlight, it will always match. It will rotate the flashlight itself to match the stuff. And because we're rotating the entity, which is like the entire thing, the light, which is a component, will also rotate as well. Okay, and then is already holding. What this does is it creates a variable called if it's holding false. I mean, I could probably do this an easier, more efficient way, but for now, this is what it is. If it's holding, it initializes this as false. It goes through the simulation entity, finds every flashlight component, and then it checks if there is a flashlight component which is assigned to an agent that is the same as, and then return this value. So if no one is holding any flashlight, this will fail. It'll be false. That means you're not holding a flashlight. So that's what this is for. All right, well done. Made it to the end. Well, pretty much the end. Here are some extras, I guess. So mainly when you set the origin of an entity to the player and the player dies, right? What happens is the origin that was set is sort of like removed, it's nulled, and then the entity origin is set back to the parent of the player, which in this case is the world. So the entity will stop following the player. The origin does not get set to false. Okay, it just stops following the player. So here are some things that I've done to handle that situation in the flashlight. So first is this value here, and it's important if the player can, if you know the player can never die in your experience, just set this to false and it wouldn't run unnecessary functions. But if they can be eliminated, set this to true. And then I have this value, which is sort of like it's an int on elim. It's sort of like what you want to happen. So when the player dies, do you want to regrant the flashlight upon the player respawning? Do you want to remove the flashlight from the world entirely, or do you want the flashlight to drop where the player dies? So that's 0, 1, 2. You would just set this in to any of these values. And so I'll go over where this shows up. This shows up in my pickup flashlight. So when you pick up the flashlight and this is happening, if the player can be eliminated, it spawns a function which is handle owner elimination. It's here at the very end. So I'll just go over what this is. First of all, the function just starts a race, waiting to see if racing between the player being eliminated or the flashlight being dropped. If the flashlight was dropped, it will just exit out of this. And this as well is, it's an event that I defined up here. So when the flashlight is dropped, which is right here, it signals this event, which will effectively terminate this function from this loop, because yeah, it'll terminate the function basically. Okay, but if the player does die, then it will exit out of this race and it will go on to, based off of what this value is here, it will do several things. So I'll just go over the last two first, and then I'll come back to the first one. So if you had set it to remove, which is 1, it would just remove, it will get the parent, which is the flashlight root, and then it will remove the parent from the world. So it'll also, naturally handle cleanup. And if you set it to drop, so if it is 2, then it will just drop the flashlight where the player died. And that will respect, if you have drop with feet on and all of that stuff. But if you have it set to regrant, and then I get the 4th character of the agent, and then I get the flashlight root, which is the parent of this entity. And then right after that, I will set this to false. By setting this to false, it would, it would go up and, it would basically it would cancel a bunch of stuff up there. And then I will loop. This is just waiting for the player to respawn. So depending on, you could have custom respawn times, but when the player does eventually respawn, then I will do all of this. And which is, I will create a new instance. I will create a new prefab, because I could attach this one that already exists back to the player, but for me, just not worth it, because you have to do a lot of stuff to, clear origin, blah, blah, blah. So instead, I just create a new instance of the prefab. This is my prefab. And then I add this instance to the simulation entity. This is just a helper function in my helper functions that basically just returns the simulation entity. So that's all that is. So I'll add this flashlight instance to the simulation entity. Anyway, so I add the instance to the simulation entity, and then I set the global transform to be the player. Because when you add it to the simulation entity, it goes to the 0, 0, the origin of the world. So I set it to be at the player so that I can, so it's closer to the player. And then I call the pickup, and then it will animate from inside the player to the player's location. And then finally, I remove this. This is the current flashlight. So it will remove this from the world, which is what this is. Okay, I don't think I went over the flashlight manager, but just in case, we'll go really quickly over the flashlight manager. It's an extra device that I have. Sure, why not? That what it does, it just lets you, grant and take away the flashlight via any devices you want, and also via your code. So you drop this in the world, you can, let's grab this. So you could just read this. Okay, and then I have these functions here. I'm not going to go over them, but you can read them too. Okay, and that's the end of the flashlight tutorial. It's taken me a very long time, but I'm glad I finally finished.